Hello.
Hello.
Sorry, I was having a technical issue before, but it's working now. I promise I won't keep you long. We're almost done anyway. Okay.
Okay.
So let's see. Um, Now let's round up this. Okay. Now we are still on binomial distribution. And I did an example of binomial distribution. Um, we will now round up with one more example, one or two example, and then I already took your attendance, so we won't waste much time. Look at this example here. One example is good enough, I believe. It says here, it is claimed that a particular flu shot is effective.
Professor, which example is that for?
Professor, what you doing? We just getting
Yeah.
logged in. Where you at?
Yeah.
No, I'm about to start. We haven't done anything yet.
Auntie, which
Oh.
topic is this?
Yeah, I just went back and showed them that I introduced binomial distribution, and we did this example here before we left. So we wanted to finish up. I was late a little bit because of tech issue, but I couldn't log in.
Is that still binomial distribution?
Yeah. We need to solve two more examples, and then we are done.
Okay.
Actually, three examples we are done. The last example is not speak. Now, the one we did before, I showed you all these formulas, so we'll be working with that again. Let me copy this formula again. So let's do this one. It says, it is claimed that a particular flu shot is effective 70% in 70% of the cases. If a group of 15 adults received the flu shot, find the probability that exactly 10 will benefit from the shot. Now let me ask you this. How many people will receive the flu shot from this question?
15.
So our N is 15. Okay? Then out of that, exactly 10 benefited, right?
Yeah.
Yeah.
Our X is 10. Now, it said that the shot is effective 70% of the time. So our P equals 70%, which is 0.7. Okay? Or you can call it 0.70. And our Q, as usual, is 1 minus P, which is 1 minus 0.7, which is, if you do that, if you use a calculator, I always, my calculator is always playing games with me. I don't know why, but it always does that. Okay, let me see if I can find it.
I'm not seeing your screen, we are seeing you.
Yeah, I'm looking for the calculator. Wherever it is hiding, I must find it this time. Yeah. Oops. Now let's see if I can see it now. You gotta be somewhere. You must be somewhere. Where are you? Okay, let me put back the screen so you can see the screen. In the meantime, let me look for it here. Where's my calculator? I may have to open a new page because I can't see it. So I'm gonna put it here. Desmos. Okay. Right. So I have 1 minus 0.70 equals 0.30, right? So I have 0.3. Okay. So now You're looking for the probability that exactly 10. So our S is 10. So the formula we use is this. That's the same formula. Anywhere you see X, you put 10. Anywhere you see N, you put 15. Anywhere you see P, put 0.7, and Q, 0.3. So this will give us probability of exactly 10 will be equal to, it says N combination X. That means 15 combination 10. 15 combination 10, okay, times, no, I gotta make this, times P, which is 0.7, 0.70 raised to the power X. Now X is 10 times 0.3, sorry, 0.3 because say Q is 0.3, 0.30 raised to the power, well, let me fix this, okay, raised to the power N minus X, which is 10, 15 minus 10, 15 minus 10 equal, so I'm gonna, okay, so when I plug this in the calculator, let me write it down first. I got 15 combination 10 times 0.70 raised to the power 10 times 0.30 raised to the power 15 minus 10. Let us go and put this in our calculator. Okay. So we have a function, have a NCR. So 15 combination 10 means 15 comma 10. Okay. Times I have 0.7, 0.7, excuse me, 0.7, okay, 0.70 raised to the power 10, okay, times 0.30 raised to the power 15 minus 10. 15 minus 10 is 5,
5.
right?
Yes.
That gives us 0.2061. 0.2061. So I'm gonna write it down. 0.2061. 0.2061. So the probability that exactly 10 will benefit from the shot is 0.2061. Any question on that? Any question?
No.
So before I want to show you something here. You can get this answer using a table. Some answer using a table, statistical, and I have that table for you in Canvas. Let me see if I can open the Canvas now. Where is the Canvas? I think it's right here. If you go to your Canvas, you can see my screen, right?
Mm-hmm.
If you go to the this section, this files in Canvas, if you look at files, you can see, scroll all the way down. You will see where I have statistical table for you right here. This is the table we will be using. From now on, we'll be using this table. Please download it and print it out. So it's right here. See, I got it here. It's downloading. Please download it and print it. You're gonna need it from now on. So we have a copy of it. Now I'm gonna show you how we can answer the same question that we did using this table. In the question that we did, you look at that question. If you're using this table, you only need the P, N, X, and P. You don't need the Q. Okay. So our N is 15, right? our x is 10 and our p is 0.7, right? So if you go to that table, you can see that it is binomial. Let me make it a little bit bigger. Say binomial, right? Right? So you can see our n. Let's go to look at this. Our n. They use r for x, and these are the p's, right? See the p. So if you go all the way to n 15, see n is 15, right? You can see 15, right? Can you?
Yes.
You can see it, right? Or wrong?
Yes.
And our x is 10. I see this r. So it's 10. So you can see the 10 right here, right? And our p is 0.7, right? If you follow it down all the way to from 10 all the way to that, okay, it's right here. You can see 0.7, see, all the way to 10 and under 15. You can see 0.206. Let me make it bigger. Okay, now I'll repeat it again. 0.7, right? And our n is 15. If you go under 10, so if you follow it that way from 70, you can see what you have, 206, right? Can you see that?
Yes.
And then when you look at our answer is approximately 206. So again, this table simplifies the work. And we're going to use it in an example like this one here. This example will require you to calculate. I'm going to move it down. It says here that, okay, a survey found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Now, solution. This is we have our how many teenagers we are selected? 5, right?
5.
N equals 5. Okay. Then P probability there is 30%,
30%.
which is 0.3. Now we are going to use the table, so we don't need the Q. But otherwise, if you want to get the Q, you're gonna be equals 1 minus P, which is 1 minus 0.3, which is 0.7. Then it's asking us to find the probability that at least 3 out of 5, at least 3 we have part-time jobs. So that means in that case our x is at least 3 means 3 or more. So x is 3, 4, and 5. That means you have to find the probability of 3 using that formula here. That formula that looks like a monster. To find the probability of 3, then find the probability of 4, find the probability of 5, and then add them together. Now, that will take you a lot of time. So we can use the table. So that here, using the table, using the table of binomial probabilities, we have that probability of at least 3. That means probability of at least, at least 3 becomes equals probability of 3 plus probability of 4, okay, plus probability of 5. See? Now you can get this from the table right away. Equals. Our first one is, remember that our n is 5 and our p is 0.3. So let's find probability of 3, 4, and 5 from the table. So I'll take it to the table. Let me write this down before we go to the table. Our n is 5, our p is 0.30, and our x are 3, 4, and 5, right? So taking you there to the table, I will now go up to where we have n is 5. You can see it, can you?
So it's on the side.
N is on the side, R, which is x, is on the side, but P is on the horizontal right here. Can you see the P? Can you see my hand?
Yes.
Yes, that's a P. So our N is 5. See 5. S, we need X, 3, 4, and 5, right? You can see 3, 4, 5. And our
And
P is
5.
0.3. See 0.3 right here. Can you see it?
Yes.
So you go under 5. Okay, this is 3. See, for 3, and this is for 4, and for 5. So you add them together, you get the answer. So 3, we have 0.132 plus. For 4, we have 0.028. And for 5, which is 0.002. Okay, 002. So now that will give you the answer right away. So having found it, we can now go back and put it in. For 3, we have 0.132. For 4, this 4 here, one we have from the table 0.028. And for 5, this 5, 0.002. So instead of doing all these calculations, you just get it from there. And then equals adding this. I'm gonna take you to the calculator. We have the answer from there. We got 0.132, 0.132 plus 0.028 plus 0.002. We get 0.162, 0.162, 0.162. Equals 0.162. Okay, any question for this before we round up, we finish up? It's easy, right?
Yeah, there's too much work.
Miss,
Too many steps.
It ain't
Miss,
that easy.
Miss Tesha, that's sorry, Miss Spears, that's college, okay? That's college for you.
Yes, indeed. Yes, it is.
So, so now let's finish up by finding the mean, variance, and standard deviation of a binomial distribution. Okay. The mean is n times p. The variance is n times p times q. And the standard deviation is just the square root of variance. Let's do just this one is the easy part. Let's do only 2 of them and we're done. And then I will see you next week. So the first one says, this is so easy that I will do only one on this side. You will see. Solution. Okay. In this case, it says here, okay, I'm gonna use this. Oh, I see the problem is. Okay. All right. Now it says here at find the mean, variance, and standard deviation of each of the values of n. So let's try only part A because it's like I say, it's just simple multiplication. Okay, part A says n is 100, p is, so our n equals 100 and our p equals here it says 0.75, I mean 0.75. Now they didn't give us the cure, so we have to find the cure by ourselves. Equals 1 minus p, which is 1 minus 0.75. If you do this in the calculator, 1 minus 0.75, okay, 1 minus 0.75 is 0.25, okay, 0.25, 0.25. Now, you say have to find the mean, variance, and standard deviation. So mean equals, that's the formula right here. I'm going to copy it. The mean equals n times p, which is, okay, make it big. And our n is 100. So have 100 times, and our p is 0.75, 0.75. You can verify this. If you multiply 100 by 0.75, you give you 75 even. You can check it with your calculator. And variance is n times p times q. So that'll give us equal. Okay, make it 20 equals, and our n is hundreds. Okay, times p, which is 0.75, times q is we have our q as 0.25, so we can get it from the calculator. Have, so n is 100, right?
Yeah.
And so 100 times 0.75 times 0.25, 18.75. So we got 18.75, 18.75. Okay, 0.75. Okay. Then standard deviation, the square root of that. Standard deviation is the square root of variance. Okay. The square root of variance, which is equal. I'm gonna make this big. Okay, square root of variance. That means 18.75 is the variance. So the square root of that, I'm gonna put it here. The square root of, I'm not a good drawer. Okay, let me see. Let me be careful this time. The square root of that, yeah, equal 18.75. The square root of 18.75. Okay, 18.75 is 4.33. So 4.33, which is 4.33. That's it. You're finished with that. So you can try part B and C as a practice. Let's look at the application of this. Just one example, and it's the same thing that we just did. And we're done. Right. So the statistical bulletin published by the Metropolitan Life Insurance Company reported that 2% of all American deaths result in twins. If a random sample of 8,000 bets is taken, find the mean, variance, and standard deviation of the number of bets that will result to twins. Okay, solution. How many bets we are taking? How many sample of bets have we taken? You can tell us.
8,000.
8,000. So our n is 8,000.
Mm-hmm.
And our p, you say that
Is
2% of
2%.
them, right? So 2%,
Yeah.
which is 0.02.
Mm-hmm.
And our q is 1 minus p, which is 1 minus
0.02.
Sorry, 2, which is 1 minus that. 1 minus 0.02. It should be 0.9, but I'm learning the short. 1 minus 0.02 is 0.98.
0.98.
Yeah, 0.98. 0.98. So that we're ready. So we have that mean. Again, the formula, you can put it from here, becomes, okay, how many, what's the average number of bets that results to twin? Okay, so that would be, make it big. Okay, I think I have, okay, let me see. You don't want to, that's better now. Equals, I mean, is 8,000 times P, which is 0.02, equals 8,000
Equal to 160.
160.
Mm-hmm.
Okay, 0.02. Let's see if you're right. Yeah, you're correct. You're correct. Very good. So 160 bets result to twins. Yeah, result to twins.
Mm-hmm.
Result to twins. The variance is the same formula, n times p times q, n times p times q. The variance, which is make it from here, n times p times q. Okay, we have n times p times q. N is 8,000,
Mm-hmm.
p is 0.02,
0.02.
and q is 0.98, right?
0.98. Yeah.
So what answer do you got this time?
156.8.
156.8. So you guys can verify this when you got a chance. Now the last question, the very last one is standard deviation, right?
My
Yeah.
internet is acting up because of the rain. It's like cutting on and off.
What's your name? Let me make sure I have your name already checking.
Latasha Smith. It's my internet just cut out.
Natasha Smith. Okay, I got you. Check your name already. So
I'm
now
still
last,
on, but I just wanted to let you know.
no problem. Yeah. So now the last one is the standard deviation, right? So that we can go home. Sorry, you're already at home. You're already at home, so you can go to sleep, right? Or
Yeah.
wrong.
All right.
So now standard deviation, make this big. So got this here is square root of variance. Our variance is 156. 156.8.
108.
Okay. 156.8. And so we can have this this square root. Okay. All right. Equals Square root of 156.8. Let's see.
12.52.
12.52, right?
19.
19. So that means since we're using one decimal place on this one, so they can just make it 12.5. That's it.
Okay.
And that's it. Any question before we go home? I'm sorry, before we go to sleep.
Said we are going to sleep.
Any question?
No.
So let me
just make sure that you download this so I can print it out.
Yeah, I'm gonna do it right now. I'm gonna delete the one. Yeah, let me delete the one I put in yesterday. First of all, let me close all this calculators. I'm gonna close this so we have enough room for that.
No.
Then we need to close this table. Close the statistical table. Close. So close it from here. Now, what else do we have? Now you can see my screen, the classroom, right?
Yes.
The one I have yesterday, I'm gonna delete it.
Okay.
We have it was probability. Okay, right here. See, so I'm gonna delete it. Delete. So I can upload this one.
Okay.
I'll save it again, then I can upload it. Okay, got this one. So it's gone. So I'm going to upload this. Upload. I'm going to change this to enter. You can still see my screen, right?
Yes.
Yeah.
So I have it right here. Say, upload it. Now it should be there now again. Probability this, yeah, it's right here now. So I uploaded it at 9:16, which is the time now. Now it's a pleasure doing business with you guys. See you next week.
All right.
All right.
Bye-bye.
Good night.